Welcome to Brain Vision.
Chapter 3, Problem 12 says, what is an orbital diagram? Provide an example. An orbital is the location on an atom where the probability of finding an electron is at its greatest. There are many different orbitals, and a great way to represent them is using an orbital diagram. An orbital diagram is also a great way to represent electron configuration. So let's do an example. Let's say we have boron. Boron has an atomic number of 5, therefore a neutral atom of boron has 5 protons and 5 electrons. The electron configuration for boron is as follows: 1s2, 2s2, 2p1. And we know this is correct because we can count 5 electrons. 1, 2, 3, 4, 5. An orbital diagram will visually represent where those electrons are located. So an orbital diagram is shown by having a box that represents that orbital. This would be a 1s orbital. We're also going to have a box for a 2s orbital. When it comes to p orbitals, we're going to have 3 boxes. The shape of a p orbital allows it to have 3 different orientations in space. So all 3 of these boxes represent the 2p orbitals. When filling in the electrons in the orbital, we're going to do it according to electron configuration. A 1s orbital has 2 electrons, so we have 1 electron up and 1 electron down. The fact that the electrons are opposite corresponds with having opposite spin according to the Pauli exclusion principle. Pauli exclusion principle states that no 2 electrons can have the same quantum numbers. So if they're found in the same energy level, one must have a spin up and one must have a spin down. The 2s orbital also has 2 electrons, 1 up, 1 down. The 2p orbital only has 1 electron, so we'll just show 1 up in the first energy level, the first orbital of the 2p diagram. This is an example of an orbital diagram of boron in which we've taken the electron configuration and visually depicted it in exactly which orbital it will fall into.